Hello everyone, welcome to this tutorial on how to build a portable project with a Raspberry Pi. My name is Dimitris and together we're going to see how to use a Raspberry Pi and a few peripheral devices to make a fully functional IoT project. This session is divided into three parts. In the first part I'm going to give you a brief description of the project itself and what we're up to. In the second part I'm going to talk about the hardware that was used. And finally, the third part, we're going to see the technologies that were used and how all these things interact with one another. So without any further ado, let's get started. So the project idea is really simple. We want to build an IoT device which will collect data and specifically temperature, weight, a picture, and GPS location, and specifically longitude and latitude, and send the collected data to a server. Now, for this project, my personal laptop acts as the server, but the server can be a cloud server anywhere in the world. Now, the core of this project is the Raspberry Pi itself. This small but powerful Linux running single-board computer is the device where everything gets connected to and works seamlessly. I also have two waterproof temperature sensors, DS18B20, and the reason why I'm using two sensors of the same kind is to show the ability they have to communicate with the Pi with only one cable. Basically, both sensors feed their data to one bus, which is then transmitting this information to the Pi. This is known as one-wire bus system. Moving on, I have a u-blox GPS module. In case of a portable project, you might want to know the position of your device at any time. This module interfaces perfectly with the Pi via USB to TTL cable or directly to the Pi's GPIO pins. Next is a 5 kg load cell, which in combination with the HX711 module can interface with the Raspberry Pi and act as a scale for loads up to 5 kilograms. Now, at this point I need to mention that should you need to scale something heavier than that, then you might want to check a different load cell. But for the purposes of this project, this is more than enough. The next component is this little guy, the Hologram Nova. The Hologram Nova is your way to connect to the internet using cellular. It comes with its own SIM card and you don't have to worry about configuring or setting up a specific SIM card or anything like that. However, if you'd like to use a SIM card of your preference, you would need to configure the APN settings of the provider that you're going to utilize. It is pretty much straightforward. It is as simple as plug and play. Just keep in mind that this USB dongle requires 2.3 amps when it boots. So you would probably have to make sure that your power supply can give you that. Last but not least, I'm using a common Raspberry Pi camera to take a picture. And here you can have a look at the wiring of the components. Starting with the GPS module, as you can see, I'm using the 4 wires of the USB to TTL cable to connect to the module, which has 4 pins: the transmitting pin, the receiving pin, the VCC, which is the power, and the ground. The other end goes to one of the Pi's USB ports. Next, you can see here the 2 temperature sensors, which use the one-wire bus system here to transmit their data to the Pi. As you will notice, there's also a 4.7 kilo ohm resistor between the VCC and the data, which is used to avoid the floating bits and the noise in general. The temperature sensors can work with either 3.3 volts or 5 volts as power supply. And finally, the load cell. The load cell uses 4 wires which go to one end of the amplifier, and the other end is connected directly to the Pi. As you can see, the VCC goes to the 5-volt pin of the Raspberry Pi. The ground goes to ground, the white cable goes to GPIO 6, and the green cable goes to GPIO 5. You could definitely use different pins in the Pi if you want to. but you have to account for the necessary changes in the software side as well. And guys, this is the actual wiring. And once you take a look at it, you might be wondering why I'm using two breadboards. Well, I could have used a single breadboard, but I was building the project step by step and I didn't have all the components when I started. So that's the reason why I'm using two breadboards. As you can see here, I also had to deploy my carpentering skills to build this wooden construction. This part right here acts like a platform where the load is placed. Okay, so now let's move to the software part of the project. The core technology, of course, is Python, because everything is written in Python. Okay, so the data transfer is accomplished with the use of the MQTT protocol. For those of you that are not familiar with the MQTT protocol, this protocol is used broadly in machine-to-machine communication, and it's ideal for IoT projects. Of course, alternatively, I could have used the Kafka distributed platform. These two protocols have a lot of similarities, since both of them are using a broker which is handling the incoming and outgoing messages, and they both have applications which publish or produce the messages, depending on which side you're looking at it, and subscribers or consumers that receive the messages. Now, once the message is transmitted, the data is written to a database, which lies on the server side, in my case. I'm using a MongoDB to write the data, but I have also done the same work using an SQLite database. The reason why I'm using MongoDB is because it's schemaless and it's easily scalable. That means that if you want to add a new measurement, for example, let's say humidity, it would be a single line of code, as opposed to any relational database where you would probably have to add new columns and perform tasks which are database specific. Now, the final part is 100% optional, okay? If you don't want to do it, you can skip it, but I just wanted to add a reporting section so as to have an end-to-end project. So for the reporting part, I'm using Metabase, which is a powerful open source reporting tool. Okay, so now let's see how this project runs. Okay guys, so here I have my laptop, as you can see here, where a Python script is running as a service and is basically listening to any incoming messages in a specific topic. So this is, as a matter of fact, this is the MQTT broker which is up and running. And I also have the Metabase service up and running, which is right here. Okay, well, this is the dashboard. And this is where we will see the new measurement. And by the way, you don't need to worry about the code. In the description of the video, there's a link with my GitHub repository where you will find all Python scripts. And from this side, I have the Raspberry Pi with all the components, as you can see, connected to it. And here, as you can see, I have placed the load of a known weight on the platform. It's 2.5 kilograms. And I expect to see a correct measurement of the load at the Metabase dashboard. I also have the two temperature sensors. The one is right here, and the other one is right here. So the one is sensing, this one is sensing the room temperature, which is about 28 Celsius or something like that. And the other one, as you can see, is sensing the water temperature in a glass with a few ice cubes in it. Here is the GPS module, which is getting the info from the satellites, and the camera right next to it, which will take a picture once it's triggered. So here I'm gonna run this script, okay, which will basically do the following. It will connect to internet, it will get all the data, so as you just saw, it took the picture, and it will send the data. And once all data is received,
Boom, the message is published. So if we go back now to the server side, if I just refresh the Metabase dashboard. Oh, by the way, here you can see that we actually received the message. So the message is received, the data was saved to the MongoDB, and the image is saved to the disk. So back to the Metabase. So here you can see that now we have 18 measurements. Previously we had 17, and this is the latest one. Okay, so here we have, as I told you, 28.3 Celsius. It's the inner temperature. 9 degrees is the temperature of the water right now. The weight is 2.52. Okay, we have a discrepancy of 0.02 kilograms. The GPS longitude and latitude, and here we have the binary image. Note that you can display the data pretty much any way you like, so that's why I've made a few reports just to show you the different ways you can have to represent the data. So here basically you can see all the data. Okay. Here you can see some trends like the inner temperature fluctuation, the weight fluctuation, and of course a map. And if I go right here, this map is basically showing the location where the measurements were taken from. Okay. Oh, and by the way, the image was saved here. This one. Okay, it's not a fancy image. It's just the bottom right corner of the monitor, because this is where the Raspberry, the Raspberry camera is looking at. But you get the idea. Okay, so I hope you enjoyed the video, guys, and if you did, give it a thumbs up and leave your comments below if you have any. And thank you very much for watching.